Okay, back to fractions. So we were talking at the end of yesterday just adding and subtracting fractions. And we looked at, well, you know already that you have to have the same denominator. I just asked, why do you have to have the same denominator? Don't think we did actually talk yesterday about why we need the same denominator. We talked about how we can show that multiplying top and bottom gets you an equivalent fraction, right? I think the last thing we mentioned was, well, if you've got 2/3 and you multiply the top and bottom, multiplying the bottom, the denominator, halves the size of the fraction, okay? And multiplying the top by 2 doubles the number you have. So that keeps, if you half the size of the fraction but double the number you have, keeps the amount the same, okay? So that's why multiplying top and bottom gives you an equivalent fraction. I guess the thing that we should talk about is, why do we need to do that? Why does it make sense? And normally I would say, well, if you don't think of it as just numbers, if you think of it as words and names, okay, all right. For instance, if I say to you, I've got 4 boys, 3 girls, and I want to add them together, what do you say? Okay, but you haven't added them together. They're still boys and girls. They're separate.
Add boys and girls together.
Exactly, you can't.
Oh.
That's my point. You can't add boys and girls together. They're different. All right. What would you do though if you say, well, you've got 4 boys, 3 girls? You would say, I have 7 students or people, or well, you make a new name. Okay, so that you can add them together. So you change boys and girls into people. You give them a different name. You haven't changed them, but you have changed their name so that you can put them together. And it's the same with fractions. Halves and thirds, they're different. They're different sizes. It makes no sense. 1/2 plus 1/3, stick them together, you still have a half and a third. So what you need is a common name so that you can actually say, I have this many of this. Does that make sense? So that's why we have to do it. It makes no sense to add 2 different sizes of things together. Alright? So, you know, just to recap then, so if we do 1/2 plus 1/3, how do we go about doing? Find the lowest common multiple, which would be in this case 6. So I'm going to say, well, I'm going to write 6 and 6. Alright, so I'm going to say it in full. So what I've done here with halves, by turning it into sixths, I have made each piece 3 times smaller. Yeah? Yep. So a sixth is 3 times smaller than a half. Therefore, I have to have 3 times as many of them. So instead of 1/2, I would have to have 3 sixths. So a third of the size of the fraction, I need 3 times as many. In the same way, a third to make sixths, I need to cut them all in half to make them half as big. So I need double the number of them. Okay. So now I've changed their names. It now makes sense to put them together. So 3 sixths and 2 sixths is 5 sixths. And also, it's this name thing which stops me making the other common mistake, which is to do what? Add the bottom together. Yeah? A lot of people would go, it's 5/12. Because they think you just add and add. Okay? But if we think of it as names, if we actually say it to ourselves, 3 sixths plus 2 sixths, it makes sense that we have 5 sixths. Because what I would say is, this number, the denominator, okay, for me, the nominator, do you know what nominate means?
Delegate.
To elect, to designate a name, or
Nominate.
to nominate it, you give, put it for. So I would say the denominator also, for me, I like to think of this as the name of the fraction. Okay? So if I think of it as a name, it now doesn't make sense to add those two together because they're just the name. And the, what's it called? The numerator. And numerator is the number of them. Okay? So numerator is the amount I have. So we have an amount of a certain size, so name, but it's also the name links to the size of the fraction. Okay? Alright? Or a really loud phone. So when we add together like that, does that make sense? Now don't forget, what we're trying to do now is go from this to algebraic fractions. Alright, and they do get quite complicated, but the same things apply, the same rules. And before we do that, I just want to go to one final thing. How would you simplify a fraction? I know you know how to do this because we've done, but if we say 12 over 36 again, it's the same as simplifying beforehand. What do we do again? And why can we?
Well, we'll find the highest common.
The highest common factor. So find the highest common factor. That's an important point. The highest common factor. So in this case, the highest common factor is 6. So I've got 2 times 6. Is it 6? It's not 6.
12.
It's 12, isn't it? Yeah.
Wow, come on.
So it's 1 times 12 over 3 times 12. Now Lucy was telling us yesterday what actually happens at this point. It's not that you cross them out and they just puff into mid-air. What happens? 12 divided by 12 is 1. So we actually have 1 over 3 times 1. So we can actually say that 1 over 3 is the same as 12 over 6. So what we've been doing before, but in reverse. So this is an important aspect as well when we do it algebraically too. Right. Now what I would like you to do before we move on to the algebraic stuff, could you, in bullet points in your notes, just summarise the things that you know you can and know how to do with fractions. So it's multiplying, simplifying, adding, subtracting, mixed numbers, whatever it is. Could you just summarise? You can chat to each other, but write a few bullet points, just things that you're allowed to do with numbers. If you need to give examples, fine, but just a few bullet points of what you are allowed to do. Allowed. So, first of all, let's have a look at this illegal cancellation thing. Let's look at the thing people do wrong and they're not allowed to do, and let's try and understand that, because it's a really great way of making sure you don't make mistakes, is to know what those mistakes are. Right? So if we have a look at this example, a plus 3 over 3. So we have an algebraic fraction because it's a fraction and it's got a letter in there. Now, if you think of it as just crossing out numbers on top and bottom, you'll think, oh, well, okay, I've got a 3 on the top and a 3 on the bottom, so I can cancel it out. And, well, actually, do you know what some people, I won't even write the one, they cancel it out, 3 and 3, and it just becomes A. Right? That's what some people think. Because they just, poof, magically disappear. The 3 cancels the 3 out. Alright? Another thing that is wrong and people would do would be a plus 3 over 3, and they would cancel the 3 with the 3, but this time put a 1 and a 1 and get left with a plus 1, which is also incorrect. Okay, we can't do that either. Right? And that's what happens if you just think of it as crossing numbers out. Okay. However, if we think of it as, well, it's a fraction, how do we do a fraction? Well, we split the top and bottom and find a common what? A common factor, and then the common factor over itself makes you multiply by 1. So that's what we're looking for. And if we look at a plus 3 and 3, well, is there any common factor in a plus 3 and 3? Well, no, you see, because factors are only what you get when you multiply.
1.
Right? Exactly. The only common factor in this is 1. Alright? A plus 3, A and 3 are not factors. Factors are when you multiply. So the only thing I could do is say, well, that's 1 times A plus 3 over 1 times 3. My common factor is 1. But 1 over 1 makes 1, and that doesn't help, doesn't change anything, does it? So there's no point in doing it. But that would be the process we would do. So the 1 over 1, and then that would be multiplied by a plus 3 over 3, and the 1 over 1 is 1, but we've got the same thing that we started with, so we've kind of gone through a process that doesn't help. But as long as you understand that these two here are the big mistakes that people make, and that's because they think of it as just crossing out numbers, and it isn't. It's not just crossing out numbers. Right?
What is a times 3 divided by 3? Would it be a plus
Okay, so let's have a look at that one. So there is no simplification. So if we did 3 times a over 3, a times 3, we can, because now it's 3 times a over 3 times 1, and we kind of need that. So then it's 3 times 3 over 3 times a, and the 3 over 3 is the 1. It's not nothing, it's 1. 1 times a, so we just write a. And that is when people go, oh, cross and cross, boof, they're gone, right? And it works for that case, but if that's the way you understand it happening, it won't work for the other cases, right? Make sense? Okay.
So wait, all of these are compared to.
No, so this one is correct, that one is correct, but there's no point because it doesn't change anything. The first two, so we'll write correct method, okay, and these two up here are common mistakes, should we say. Alright. So these ones are the mistakes not to make. And like I say, I'll reiterate, I keep saying it, that's because people do that because they think they're crossing things out and they magically disappear. And you've got to think, well, I've got to break it into factors, and then the factor divided by itself gives me 1, so 1 times something. And that only works if it's 1 times, because obviously if we end up with 1 plus, it does change it. We can't forget about a 1 plus, but because it's 1 times, we don't need to worry about it. And that is like a big principle of all of these algebraic fractions. It's just that factorise. Now you need to be able to factorise. which I guess is the problem when we get to quadratics and things like that. So what I'll do now is I'll go through the two examples and then you'll be able to work through some of those in the exercise, finding which ones are challenging you. Alright. Are we ready? Can I go to that point? Is that right? You're still writing? Okay, so let's have a start looking at, we're going to simplify. So just like any other fraction, when you simplify, you try and find the common factor in the top and bottom. Okay, so we've got simplify 2x squared over 4x. So what we're looking for is the common factor in the top and the bottom. So if I think of it as 2 times x all over 2 times 2 times x. I've really broken it up into all of its factors. So the common factor would be, there's 2 over 2, which makes the 1 times, and there's also the, I'm going to choose these two, it doesn't really matter, the x times the x, which also makes a 1. So we could, again, I'm writing all of this out to help explain. You don't need to, you could cross out as long as you understand what you're doing. So 2 over 2 becomes a 1 times, x over x becomes a 1 times, and x over 2 is still there. So in total, we end up with just x over 2. Right. Now in reality, of course, what you might choose to do is say, right, 2x is there, that's what the 2 means, so I'm going to cross one of those out and get rid of that one. Okay, and then the 2, well, there is a 2 and a 4 gives you a 1 and a 2. Okay, so we're left with 1 and x on top, and this x has gone and we've got 2. So that would be kind of the shortcut method of crossing things out. You end up with the same answer. As long as you understand you're not just crossing things out and disappearing things. Right? Yes? No? Makes sense? Okay. Alright. I tell you, do you... Let's do them. Let's do B and C as well, just in case. Alright. Are you ready? Ready for this? Next one. So we've got 6xy over 3x cubed. And I'll do it the long way. So I'm noticing the 6 and the 3, so I'm going to do 6 is 2 times 3, and then it's times x times y, and then underneath is the 3 times x times x times x. This is the second example, B, in the same yellow box, at the bottom of page 340. So I've got the times 3 and the divide by 3 would give me my first 1 times. This x with this x would give me my second 1 times. And then the rest of it's alright. So I've then got 2y left on top over x squared. So that would be my final simplification. So this would equal 2y over x squared.
This is pretty easy.
Good. Again, if I did it the quick way, feel free to not worry about it. But I would say, right, 6 and 3 cancels down to the 1 and the 2. The x cancels with one of these x's, so that becomes a 2. And then that's it. So I get 2y and x squared. Yeah. Right. Are you ready for the next one?
Yeah.
Okay. So if we have a look at x plus y over x.
Such as y.
It can't be done.
Is there any
Addition.
Because there's addition in there, isn't there? What's the only common factor between the top and the bottom? 1. So this one cannot be simplified.
I said that.
Oh, it's in the book.
Cannot be simplified there. Alright? I tell you what, I'll go straight to the next examples because I think you're doing quite well. Unless there's anyone that thinks, no, I'd like to practice just that level. Should we go to the next one? Because I think actually you'll get it. It'll make perfect sense. The next one I'll do. Do you want to do a bit of practice on this, please? Okay. Well, I'll tell you what. If you want to go on and look at the next example yourself, feel free to do it and then carry on. If you are happy where we are just for the next 10 minutes, because I'll do it in 10 minutes time, which will be the end of the class in further 10 minutes. Have a look at just question 1 from exercise 16A.1. So have a look at question 1.
We
Alright.
can look at the other one if we want to.
You can have a go with the next exercise. If you want to move on yourself, that's fine. If you think, no, that was really easy. If you want a bit of practice, do question 1.